Thanks for joining me. So in this little tools in action session, I'm going to talk about the C4 model and my Structurizr tooling. Before I get into the actual demo part of this, I do need to do a very, very quick introduction so we're all on the same page. So software architecture diagrams have historically been very bad. I'm sure we all know this, we've seen it in the past. So a number of years ago, I created something called the C4 model for visualizing software architecture. If you've not seen it, you can go to c4model.com. There's a whole website there that tells you how the thing works. It's essentially a hierarchical set of diagrams that allow you to describe your software architecture from different levels of abstraction, showing different levels of detail. And the concept here is diagrams as maps. So I want to be able to have different types of diagrams at different levels of detail that allow me to tell different stories to different audiences. Some of these people are technical, some of them are non-technical. I'm going to focus on the top two levels first. The top level is called the system context diagram. And in order to draw a C4 system context diagram, those are the questions that you need to ask and answer. So what's the thing we're building? What features sit inside it? What features sit outside of the thing we're building? Who's using it? And what are the system-to-system integration points? Answer those types of questions, and you can draft up a C4 system context diagram. So if you've not seen this before, this red box here, that's the system that was being designed. This group has identified a couple of user types, roles, actors, users, personas, and a bunch of external system dependencies. So this is the context of the system that we are designing and describing. Now we can do the Google Maps pinch to zoom thing onto that red box, drop down to level 2. Level 2 is what's called a container diagram. This has nothing to do with Docker. I'm sorry, I got the name first. I know that's irrelevant. But by container, I mean an application or a data store. So the software systems we build are made up of applications and data stores. And when you're drawing a container diagram, it's a different set of questions. Answer those questions, and you can draft up something like this. So we zoomed into that red box. We're now showing the applications and the data stores that make up this particular system. And you'll notice, and this is going to be important for later, we still have our people. Oh, you're right there. We still have our people and the external systems that we have a connection to around the edge. So that's the summary of C4. It's a set of hierarchical abstractions, a set of hierarchical diagrams. It's notation independent, and it's also tooling independent. Right, so in terms of tooling, most teams generally use the general purpose diagram tools, Visio, Lucidchart, OmniGraffle, Draw.io, and so on. These are fabulous tools, but I don't recommend them for drawing software architecture diagrams. Why? They can't help you. So there are not many rules in C4, but one of the rules is this. If you're drawing a context diagram, the context diagram should only really include people and software systems. If you're using a general purpose diagramming tool, it can't enforce that rule, and it's very easy to start dropping things like components onto a context diagram, which is not in the spirit of C4. It can't help you when you have multiple diagrams. So something I said earlier, you need to repeat elements across your different levels of detail. You'll repeat your users on your context and your container diagram. And that's easy to do with a tool like Visio. You just copy paste the boxes and the arrows. But if you start renaming things across your diagrams, you need to make sure that you rename them across all your diagrams. So the general purpose diagramming tools can't help you with things like consistency. This is pretty evident. If you try and dump these things out to text files to put them into Git, you'll find the content and presentation is mixed. You change the color of a box and you get a completely different XML file. And that's also hard to diff, of course. And you can't automate these tools. So that's why I don't recommend general purpose diagramming tools. Some of you might be thinking, well, Simon, tools like PlantUML and Mermaid fix some of these issues. And you are correct. So there's a whole thing out there around diagrams as code. PlantUML, Mermaid, Graphiz, Dot, there's a bunch of them. These tools do resolve some of those issues. You can check these things into source code control because they're just plain text. We've got lots of tooling to support text. Most of these are automatic layout. You can integrate them into your CI/CD build process. So there's tons of good things going on here. However, these tools are still fundamentally diagramming tools. So take something like C4 PlantUML. C4 PlantUML is a bunch of extensions that give you C4-esque terms, essentially. So this allows you to craft up this diagram with a person, a system, and a relationship. This is still a diagramming tool, though. This is one text file with one diagram. If you want a second diagram, you need a second text file. We can do global search and replace. We can do including elements across multiple text files, but this just gets harder as your diagrams and models scale. So this is what I'm calling diagrams as code 1. Your 2 diagrams, you create 2 text files. This works for small systems, but at some point in time, and I've seen this a bunch of times in the past, people have gone down the C4 PlantUML route, and they've realized at some level of scale, they just get stuck. It just becomes hugely unmaintainable, and they're having to keep all these things in sync and up to date and consistent. So I want to shift the narrative away from diagramming and back to modeling, which is something we did in the late 90s, early 2000s, and then Agile came along and we threw all that stuff away, and everybody's scared. I'm going to talk about Rattle Rows now. A model is very simple. It's a single definition of things, and you surface or show those things on diagrams. That's it. That's the concept of a model. So this little session is about models as code, or actually more correctly, I guess, it's models as data, diagrams as data. So back in the pandemic, I had some spare time for obvious reasons, and I built a bunch of tooling called the Structurizr DSL. So I have previously talked about things like my Structurizr tooling. This is all built in Java. It's all open source. During the pandemic, I built an additional layer on top of that tooling called the Structurizr DSL. It's a text-based tool specifically focused for building C4 diagrams. And this is what I'm calling diagrams as code 2, or really models as code. We craft up a single definition of things, a bunch of views, and we create multiple diagrams automatically based upon the definitions in the model. The concept we're going to see here in the demo is what's called a workspace. A workspace is nothing more than a wrapper for a model, which is your definition of elements, so people, software systems, relationships, and a set of views. And the views get rendered to diagrams. If we get time, I'll also show you that you can add supplementary documentation in here as well. 2 things worth noting. Number 1, this workspace concept is authoring tool agnostic. So there are a bunch of tools that you can use to author these workspaces. I'm going to show you the Structurizr DSL, but you'll find other options on GitHub. And this tooling is also rendering tool agnostic. So I'm going to show you a bunch of rendering tool options. So let's get into this. I'm going to open up my command prompt. So on here, I have a Docker image called Structurizr Lite. This is a Spring Boot backend, JavaScript frontend, all open source, all on GitHub, prepackaged as a Docker image. I'm going to boot that up and point it to a folder on my desktop that doesn't yet exist. So this is called Structurizr Lite. And this is an app I built to essentially visualize and author these diagrams. So that's booted up. And now what I have on my desktop is that DevOps folder and this workspace.dsl file. So this is the Structurizr DSL. Here's the definition of our workspace, which is a wrapper for a model and a set of views. What we're doing here is defining a person with the name user. We're assigning that to an identifier user. We are defining a software system named software system. We are defining a relationship between the user and the software system with the description users. So that's our model. It's a person, a system, and a relationship. We're then defining a system context view from the C4 model. The scope is the software system. Ignore that, it's just a diagram identifier. And we are saying include star. What include star does it includes that software system and anything connected directly to it. So that's our DSL. How do we get some diagrams? What we do is we go to localhost 8080. So this is where that Docker image is now running. And here we have a diagram. So this is the Structurizr Lite UI, standard looking diagram editor. Worth noting, you can't modify the model through this UI. You can only move boxes around, but you can move things, you can break the arrows, you can move the text. So the way I want people to use this tool, the way I envisage people using this tool is manual layout. So automatic layout is fantastic, but I always find it doesn't work once you get past like 6 boxes. If I'm drawing an architecture diagram, I want to tell a story. I want my people in the top and like flying down through the diagram, for example. So by default, manual layout. So now we can go back to our definition and I can start changing. So I can call this my business user, save, go back here, refresh. There's a merging algorithm built in that tries to figure out what you just changed. So now we can go and we can change a few things. Now, some of you might be thinking, well, where's the diagram layout? Because it's not in the DSL file, and you are absolutely correct. It's in this JSON document that's now sitting next to it. So this is actually the data structure that's used behind the scenes here. Let me open that in this one instead. So this is the canonical data structure used by the tooling, and it's really just a representation of the same thing. And here are the XY coordinates of those boxes. So now what you can do is you can stick these two files in Git along with the script to boot up Structurizr Lite against that folder, and anybody on the team can get that same set of diagrams. So that's kind of quite nice from a workflow perspective. What I'm going to do now is I'm going to turn on auto layout just because it makes doing demos easier. There we go. So let's imagine this is our context diagram and we're happy we're done. And now we want to draft up a container diagram. How do we do that? What we do is we go here. This is our software system definition. Open up some curly braces. And now we can start adding containers inside our software systems, reflecting the abstractions in C4. So we're going to have a web app. That's going to be a C4 container called web app. We're going to have a database, which is going to be a C4 container, and we're going to call that database schema or scheme. And we're going to say that the user has a link to the web app with the description of users, and the web app has a link to the database with the description of reads from. If I save this and refresh my browser, what's going to happen? Nothing is the correct answer. So I've added elements, but the elements are non-visual. In order to get them on a diagram, I need to add a view. So what do I need to do? I need to add a container view. How do we do that? Go down here, copy paste that, change that to container. So we want to create a C4 container view for the software system. We'll change this identifier. Include style now does something different. It says include the containers inside that software system and the high level abstractions that connect to them, and apply automatic layout. Save that, go back here, refresh, little magnifying glass, double click, and there's our container diagram showing our user to our web app to our database. Don't repeat yourself is a mantra we always talk about in software development, but I literally have just done that. If we look here, these two lines are essentially the same, aren't they? What I can do here is I can delete one of them, and you have to delete the right one. I'm going to delete the top one. So now I'm going to define the user to the web app and the web app to the database. Save this, go back here, refresh. So these two arrows are the two arrows in the text file. If I go back to my context diagram, it still exists. So this is a feature called implied relationships. Because there's a link between the user and the container resides inside the software system, there is an implied link between the user and the software system. So this is a really nice feature that I added so you can reduce the number of relationships that you are defining. You can customize this, you can get in behind the scenes, add some Java code, turn it on and off, do what you want. There's a bunch of stuff you can do here. So we have some diagrams, but they look kind of ugly. So let's fix that. How do we make them look better? If I turn on tooltips, element and person. So these are text-based tags in the same way you'd have CSS classes for HTML elements. So people have an elements tag and a person tag. Software systems have an element tag and a software system tag, likewise for containers. So what I can do is I can go down here and I can create a bunch of styles for those tags. So I can create an element style for the elements tag. Backgrounds blue, color white. That changes all elements across all diagrams in one go. So no messing with palettes and Visio and stuff. If I want to change the person into a person shape, it's the same deal. Create an element style for person tag, shape person, done. If I want to go down here and change the shape of this database schema to be like a database shape, a cylinder shape, I need to add a new tag to just target the styles of that one specific element. How do I do that? I go to here, open a curly brace up, tags, database, go down here, elements, database, shape, cylinder. And let's also change the backgrounds. One of the things I talk about in C4, if you've ever seen any of my presentations, is that any diagram should have a diagram key. So this tooling automatically generates you a diagram key based upon the styles and all the metadata that sits in the model behind it. So that's my kind of super short demo of the basics of the Structurizr Lite tooling. There's a bunch of other stuff I want to show you now. So as I said before, this tooling is rendering tool independent. So what I'm going to do is I'm going to shut down that example we've just been looking at, and I'm going to boot up the example diagrams that you'll see when you go to the c4model.com website. This is for the Big Bank PLC internet banking system. So if I open a new tab, go to localhost 8080. So this is the system context diagram for the internet banking system. Double click, get to the context. Sorry, that was the system landscape. This is the system context diagram. Double click, get to the container diagram. Double click, get to the component diagram. Double click, get to the code level diagram, which in this case is a static PNG file, but you can also insert PlantUML and Mermaid here if you want to. And this tooling also supports the dynamic diagram, which gives you a UML collaboration style animatable diagram, so you can show individual flows or features, and it also supports the deployment diagrams from C4 as well. So that's the set of example diagrams you'll see on the C4 website rendered through my Structurizr tooling. If I now shut this one down and boot up a different Docker image. So there's something called Structurizr Site Generator, which is, what is that? Failed to create task. Oh no. Are you trying to, yeah, I know why. No. Sad face. Forget that one. So Structurizr Site Generator is another Docker image, and it gives you an alternative rendering of that same set of diagrams, essentially. What I can do instead is go to here. If I go to the Structurizr demo page, which is structurizr.com/DSL, there's a Big Bank link down here. So here are the examples I showed you before. There is a PlantUML version of those same example diagrams. There's also a C4 PlantUML version, and there's a Mermaid version. So there's a Structurizr CLI tool that you can use to basically export views. You define it in your workspace to various formats. The Structurizr Sites Generator essentially bundles the C4 PlantUML exporter and puts that into a nice web-based interface, which is not working because I have no idea why. So that's one way you can visualize your workspace in a different manner. There's also something called Structurizr Mini. So the Structurizr Lite UI is open source, and somebody has taken the open source UI and they baked it into a lighter version of Lite. So if you just want a very simple way to publish diagrams on your intranet, for example, Structurizr Mini is one way to do that. There's also a tool called Ilograph, which I'm going to show you a little bit later on as well. But if I go to this Ilograph tab, this is also available from the Structurizr CLI export. So I'm going to take this horrible looking YAML format. I'm going to go to the Ilograph website, which is here. I'm going to go new diagram. I'm going to discard that one, copy my YAML in, minimize that. So here is essentially the same C4 model, software systems, containers, components, just rendered in a different tool. So this is quite nice because it's interactive and it's zoomable. So if you have a very large model, a very large software system, or maybe a system of systems that you're trying to model, this is another great way to visualize and explore that larger data set, essentially. So this is why I kind of said this is really models as data or diagrams as data. So that's a quick kind of overview of how you can render these things in different ways. One of the other demos I would like to show you, hopefully this will work, is how do we demo a large, kind of more complicated architecture. So what I have prepared here is a kind of microservices style architecture. Stitch that, stitch that, stitch that. So imagine we have a service-based architecture. Let's go full screen. So here we have a single software system that is comprised of 8 services. every service on this diagram is comprised of an API thing and a database thing. So here's service 1. It's a combination of the API and the database. There's 3, there's 7, etc., etc. So essentially, I've color-coded all of the services here. This diagram looks okay, but as you add more services, as you add more boxes and arrows, this diagram becomes more complicated. So the question becomes, well, how do we deal with scale? How do we do C4 at scale? This diagram is showing you 8 services. What you could do instead is draw 8 diagrams, each focusing on one single service. And that's essentially what we have here. So here is the service 1 version of that same container diagram. It's still showing the same abstractions, but we're showing a subset of the entire picture. And what we're doing is we're showing service 1, things coming into service 1 and things exiting service 1. Ditto for service 2, ditto for service 3, repeat, repeat, repeat. With the Satellite Visio, this is a nightmare because you're now copy and pasting things across different diagram canvases. With the Structurizr DSL tooling, it's relatively straightforward. So this is my definition of a service. It's a group of an API container and a database container. So this same pattern's repeated a whole bunch of times, so we can skip all that. This is the all container, sorry, that's the all containers version here, include star. This is the service 1 version of the diagram. It's essentially saying include service 1 that sits inside that software system, include things coming into that service and things exiting, leaving that service. So the inbounds and the outbound, the afferent and the efferent couplings, if you want to use that terminology. So what we have behind the scenes here is essentially a model of elements and relationships. And there's an expression language built into the DSL that allows you to slice and dice things on the diagrams. This also works with the rendering tool agnostic part. So what we can do is we can take the same demo. So I can go to my Structurizr DSL demo page, click the microservices link, get this, go to the service 1 version, and we have the PlantUML version rendered here. So all of the rendering stuff is done after all of the expression language stuff is done as well. But we have options. So that's option 1. We draw multiple diagrams showing a single service each. The other thing you can do, go back to full screen, is you go back to this diagram, and in the Structurizr Lights tooling, you click this button, and you get a very therapeutic D3 force-directed graph. So this is essentially showing you the same information as that single diagram. Every circle here is a C4 container, but this is interactive. It's got tooltips. We can start clicking, show nearest neighbors. There's a quick find feature. So again, this allows you to visualize and explore a larger quantity of data in a much more succinct, concise way. So that's option 2. The other option is, of course, to use that Ilograph tool. So we can go to here, and again, you can get this via the CLI. Go back here, go back to Ilograph. I would like to new diagram, discard, paste it in. So here we have that same model, essentially now rendered through the Ilograph tooling. And again, it's all nicely interactive. We can zoom and filter and things like that. So when people say C4 doesn't scale, that's absolutely not the case. It's really the tooling that you're using can't scale. So on that note, the one final thing I really want to show you is really how do we solve this problem? So I see lots of organizations who are adopting my Structurizr tooling. Every team is kind of defining a single workspace for their own service or system. There's a thing called the Structurizr on-premises installation. This is also all written in Java on GitHub. It's all open source. You install this on a server somewhere, and then you can publish multiple workspaces to that single server instance. So I see lots of teams doing this, and they're like, this is great. All our teams are autonomous. We have decentralized documentation. But how do we, as like a CTO or an engineering manager or a bunch of enterprise architects, how do we get a single centralized view of all of the systems and how they connect? And it's a really interesting problem, and it's actually really straightforward to do. So what we do here is we build a system catalog. So the example I'm going to show you in a second uses the Structurizr DSL. And in this thing, we're going to define all of the services or systems used across the organization. We're then going to have every team extend that single system catalog and add information about their own single software system. So now we have a bunch of things that have some degree of referral integrity. So when they all talk about system A, it's the same system A. And now what we can do is we can write a Java program. So all of the Structurizr tooling is written in Java. So we can write a Java program that essentially parses that system catalog, goes and loads all of their individual software system-based workspaces, basically merges and aggregates the information together, finds the systems, finds the links and the relationships between those common systems, and drops that into a fourth workspace, which then becomes your system landscape. So if you go to my GitHub repo, there's an examples enterprise folder, and this is where you can find all of these things. And what I'm going to show you here is example one. And example one is exactly what I've described to you. This is our system catalog. So we're defining an order service, an invoice service, and a customer service. There are no views defined here, and there are no relationships. We then have our customer service, which is extending our system catalog. It's extending just that customer service, and it's adding C4 implementation details for that customer service and adding some views. The invoice services are doing the same thing. It's extending the system catalog, extending just the invoice service this time, adding some implementation details, ditto for the order service. So what this example does is it simulates three teams posting or publishing those workspaces into a single on-premises installation. This basically boots everything up from scratch. So it's using test containers to boot up the on-premises installation via Docker, feeds all those three workspaces in, creates a new workspace, pulls them all out, does the aggregation, and then generates the landscape workspace for you. So here's the customer workspace. So this is the customer service and the container diagram. This is the invoice service. So you'll notice we have a link from the customer to our invoice service and out to the customer service. And the same is true of the order service. There's a link from the customer and out to the customer service. And here's the landscape that was automatically generated for us. So it's basically aggregated all of the relationships across all of those three workspaces and dropped them into a single landscape workspace. So this is a really nice way to have your teams do decentralized documentation, but still retain some degree of a centralized view of what's going on across your enterprise. There is one more little thing I want to show you related to a presentation I went to this morning. I went to the ADRs talk. And there's kind of lots of questions about like ADRs and how do you work with them and how do you publish them and search them and that sort of thing. My Structurizr tooling will do that for you as well. So what I have here is another example. This is the financial risk system example. So here's the financial risk system. It's a software system. And I'm using the Structurizr DSL ADRs keyword to say, go and pull in all of the ADRs in that ADRs folder. That folder looks like this. So the Structurizr tooling supports Markdown ADRs in ADR tools format, Log4Brains format, and Matter format. And these are all just bog standard ADRs as Markdown text files. We go to Structurizr Lite. So Structurizr Lite supports diagrams and documentation. This is supplementary Markdown documentation. We go to the decisions link. I built a little decisions explorer essentially. So this is a summary of all of the decisions it found in that folder. They're all clickable, hyperlinkable, etc., etc. There's also this little decision explorer. So if you find a decision that's been superseded, it will track the links via the kind of hyperlinks between them and allow you to navigate around your decisions. And it's searchable, etc., etc. So again, ADRs are fantastic. You should definitely use them. This tooling allows you to bundle up a bunch of ADRs, associate them with the software system, and then visualize them, make them publishable and searchable via some sort of a UI, which I think is pretty cool. So I have 1 more minute left. In the spirit of openness, there are some other options. There's one called Overarch, which allows you to define C4 models and diagrams using the extensible data notation. Link there. The slides will be available afterwards. There's RDB model, which uses a YAML format, YAML syntax. There's a bunch of tooling around PlantUML that attempts to build a model from various PlantUML files. There's something called like C4, which is like C4, but people say it's less restrictive. It's a bit more open, but that comes with some dangers. Grab me afterwards if you want to discuss that in a bit more detail. And there's something called model, which is targeted at doing the same sort of thing I've described using the Go language and the illograph tool I showed you. So I hope you found it useful. If you want to get started, you can go to structurizr.com/DSL. That's the little demo page. You get the text editor on the left and all the diagrams on the right, and you can see the different formats. And there's a whole bunch of documentation at docs.structurizr.com, and there's a cookbook on there as well. Thank you very much.